So now we are using proportions to solve for unknown sides of a triangle. And they give us information that triangle AIM, this larger triangle, is similar to triangle LOW, the smaller triangle. And we've been given two sides, and we need to determine the missing side of the smaller triangle. So you'll notice that side AI corresponds to side LO. So we're going to set up a proportion, AI over LO, which is 20 centimeters over 16 centimeters. And that has to equal side AM and LW. So because triangle AIM is on the top, it stays on the top, so side AM corresponds to LW. And since we know that AM is 15 centimeters, we're going to solve for LW. The next step is to take just the numbers and put them into one proportion. So 20 over 16 has to equal 15 over x. And this is our very basic cross multiply and divide. We're going to multiply the numbers that are diagonal, so 16 times 15 and we get 240, and then we're going to divide by the missing, or by the remaining number, and then divide that by 20, and we get the missing side as 12. So x equals 12. Another way to do it is to use the same triangles, but use the proportions with its own self. So AI and AM should be in proportion to LO and LW. We know that AI is 20, we know that AM is 15, we know that LO is 16, and we're looking for LW. Again, you're still going to do the cross multiply. You're still going to divide by the remaining number. And you're still going to get 16 times 15 equals 240 divided by 20 still equals 12. So x continues to be 12. A key component here is to remember that if you start with one triangle on the top, like up here, we started with triangle AIM on the top, in the corresponding proportion, it has to stay on the top. Just like LO started on the bottom and it ended on the bottom. We can flip them, but we have to flip both fractions. We'll still get the same result of x equaling 12, but you have to keep track of the same corresponding sides on the same side of the fraction.